32-2, special right triangles and the unit circle. Again, going back to the unit circle, I told you that we were going to incorporate sine, cosine, and tangent all into the unit circle, which is why we had to review them. Now they don't entirely leave a lot for us to calculate here with these special right triangles and the unit circle. We know that sine, cosine, tangent have to do with the three sides of the triangle, but there are a couple of relationships that we can actually get from sine, cosine, and tangent, that we can get from doing all of this to lead us to these two very specific triangles. All right, these two very distinct specific triangles. One of them being a 45, 45, 90 triangle. So we call this a 45, 45, 90. Why? Because of 45 degree, 45 degree, and a 90 degree angles. And then the other being a 30, 60, 90 triangle because of the 30, 60, and 90 degree angles. These two distinct triangles have very, very, very distinct features that help us fill out the unit circle. What part of the unit circle are we missing? Well, if we go back up here, I told you earlier in the week that we were going to fill in a lot of these blanks. Obviously, we have blanks like here and here, but specifically the ones that I'm looking at for the special right triangles are actually these coordinate points. Where do we get those coordinate points? Well, we get them from those special right triangles that we are doing now. Okay, so 45, 45, 90, 30, 60, 90 triangles have these very distinct features. Here are the features. 45, 45, 90 triangles, all their sides can be x, x, x root 2. So across from the 45 you have x, and then across from the 90 you have x times the square root of 2. So you have x, x, x root 2 for 45, 45, 90. Very, very, very important pattern there. And then for the, I did the wrong color, but for the 30, 60, 90, across from the 30, we call that x, so that's our base, our x. Across from the 60, we have x root 3, or x times the square root of 3. And then across from the 90, we have 2 times x. All right, so let's say, for instance, this would be 3. Then across from the 90 would be 6, because 2 times 3 is 6. And then across from the 60, we could have 3 root 3 as a length. That would actually be a decimal, but we keep it as 3 root 3. Right? And that's a perfectly fine triangle. This triangle exists. If it's a 30, 60, 90, I could have 3 root 3, I could have 3, and I could have 6 as a hypotenuse, as long as it is a 30, 60, 90 triangle. Perfectly fine. Or if you go back to the 45, 45, 90, you could very easily have you could have 5, 5, 5 root 2, right? Because of the 45, 45, 90 pattern. Where does that help me with the unit circle? Now, the unit circle uses a radius of 1. This is the most important thing about the unit circle. The unit circle uses a radius of 1. Again, the unit circle uses a radius of 1. Anything that you see in the unit circle on the circle is 1 unit, quote-unquote, unit away, right? 1 of anything is called a unit. So we want a radius of 1. Our hypotenuse is always 1. Okay, our hypotenuse is always 1 with these triangles. Remember what I said? We can convert this x, x, x root 2 into 1 root 2 over 2 root 2 over 2, or this x, 2x, x root 3 into 1/2 x root 3 over 2 and 1. I'm going to do the conversion right now just to give you an idea of how I'm getting this. It is most important that you memorize this, right, these two. If you memorize this and memorize this, but here this may help you to link as to why we can do it or how we get these values. the radius needs to be 1, okay? Or the hypotenuse needs to equal 1. Well, the hypotenuse here is 2x. That's here, right? So the hypotenuse is 2x. How can I make 2x equals 1? What does x equal? X equals 1/2, because 2 times 1/2 is 1. So far, if I was to draw a brand new triangle here, I'd have the hypotenuse of 1. Then I know that x is 1/2. Where's x? X is on the one of the legs, or crossing the 30, so this would have to be 1/2. Okay, and then I know that this bottom portion has to be x root 3. So this has to be x root 3. Well, what is 1/2? What is 1/2? This is not going to write. Times root 3. Well, simply, this is root 3 over 2, which is what I get here. So I can very easily convert my 30, 60, 90 pattern into 1/2 root 3 over 2. The same thing here. Again, this is not entirely the most important thing, but if you like to have that visual of how we get there, we can convert x, we can convert this, x root 2, into 1 by multiplying it by root 2 over root 2. And then I can multiply this x to get me root 2 over root 2, and I can multiply this x to get me root 2 over 2. By doing some simple math conversions, we arrive at these two triangles. Again, if you're going to memorize anything, memorize that and memorize that. You don't really necessarily need to know the work behind it, quote unquote, the work behind it, but it is important that you know the relationship. 1, root 2 over 2, root 2 over 2. We have 1/2 root 3 over 2. Now, where does that incorporate into our unit circle? Because at the end of the day, we want to fill out these points. We want to fill out what goes in my coordinate points there. Here we go. What I can do is, if I'm given a 30-degree angle here on the circle, I can actually drop a segment there, and that creates a right angle, that altitude, right? We can create this altitude by dropping a segment there and having a right angle. I also want to reiterate that what we're talking about, and what you see in these black lines here, this is a coordinate point. This is a coordinate grid. We have a circle placed on a coordinate grid, so we should have coordinates at every point. Hence, what's in purple here, right? That's a coordinate. We need to find what coordinate that is. If you know your 30, 60, 90 pattern, or your 45, 45, 90 pattern, it becomes very easy. Not very easy, but we can make this relationship pretty easy. Easily. Okay, picture this. We have a triangle right here, right? Maybe you see it. Well, hopefully you see it. Let me draw it over here. Draw bigger than that. Okay, we know that this is 30. We know that this is 90, which means this is 60. Right, so we have a 30, 60, 90 right triangle. I also know, that was 2 raised to that, I also know that this portion right here is my hypotenuse. This portion right here is my hypotenuse. What does the hypotenuse always have to be? Well, because I know that my hypotenuse is going to be 1, I know that this is 1. The measure from there to there is 1. My radius of my circle is 1. From the center of my circle to a point on the circle is 1. So, how does that help me with the rest of it? 30, 60, 90 triangle, I have a radius of 1. Across from the 30-degree angle, what's my number? 1/2. So I know that I have 1/2 here. Across from my 60, this is root 3 over 2 if you look above. Across from the 60, I had root 3 over 2. Across from the 30, I had 1/2. So if I look here, across from the 60, I should have root 3 over 2. Across from the 30, I should have 1/2. What does that tell me about this coordinate point, though? How does that help at all? Well, this was 1/2. If we're thinking of this as a coordinate grid, I know, green, let's use blue. This portion right here is root 3 over 2. Means that I'm going in what direction? I'm going left or right, root 3 over 2. What direction is your left or right? That is your x direction. I'm going from the center, I'm going right, root 3 over 2, or positive root 3 over 2. And then I'm also going to have to go up, right? I'm going to go up, how much? 1/2. What is the up direction? That is your y. So I have 1/2 as my y. And that's how I use the 30, 60, 90 triangle in reference to these coordinate points. I have a 30, 60, 90 triangle. I write it as a 30, 60, 90 triangle, and I use those two other sides, those two other legs of the triangle, root 3 over 2 and 1/2, in my unit circle as my coordinates. Alright, the next video we are going to actually take a deeper dive in here and fill out the rest of these. 45 degrees, 315 degrees, 240 degrees, and 150 degrees. These are all degrees of the unit circle, so that is the next video. Hopefully this isn't too overwhelming for you, but I know if you break it down, think about it, really break it apart, it should be okay, right? You'll be alright. Alright.